Okay, so this is experiment 610, and for the process measurement experiment, what you're going to do is you're going to look at calibrations of thermocouples, two different types of temperature sensors, a thermocouple, type K thermocouple, and an RTD sensor. And we have two different ways to calibrate these devices. And one way is, and this is kind of important, this would be the input to your controller. And so what your controller reads isn't necessarily a temperature, but it's going to be some signal coming from the sensor going into the unit. So like for example, currently I'm looking at the RTD Pro. This is actually a calibrator. This precision calibrator is a very nice unit. I can use it to calibrate and test any of the process equipment in the entire process control lab, or in the transport phenomenon or unit ops lab for that matter. So this is a very nice unit, so please be very careful with it. I'm probably going to provide you with a instruction sheet that tells you what buttons to push specifically to go from one thing to the other, one measurement to the other. But the buttons are really pretty intuitive on this unit, and it'd be hard for you to kind of mess things up if you just read the front panel carefully. We also have a dry block temperature calibrator that I can set a specific temperature on this device. Now, it's important for you to know that once you set the temperature, it's going to take some time for it to get to the new set point temperature, and then it's going to have a stabilization time. So that's going to limit the number of trials that you'll be able to do on this particular part of the experiment. So they say that from ambient to 100 degrees C or ambient to -10, which is the range of this calibrator, it takes 10 minutes approximately. Now, if you want a specific temperature ahead of time, you can send me an email and let me know, or post a note on here when you come in to direct an order to let me know what temperature you want, and I can have it set up for you when you come in. Otherwise, it'll probably be set to something like 25 degrees or so when you come in. So it's been at 25 degrees for a long time now, so the signal should be relatively stable. And if we look at the RTD input that's coming from this probe here that's inside there, it's giving me some resistance reading. And that is what the controller actually sees. Now, inside the controller itself is a table that tells it, okay, if you're getting this signal, it translates into this temperature. And so that the controller can kind of translate that information a little bit. Similarly with the thermocouple sensor. So I have a thermocouple sensor in here as well, and I can switch it. So thermocouple input, and there's my thermocouple reading. And I want you to compare the outputs. Of course, the output of the thermocouple is the input to your controller. And in this case, the calibrator. That's where the signal is going in. And so you can compare these two signals, and you can compare changes in those two signals, and maybe determine which is a better input device for my particular process. And that's all related to the gain, which is something that you'll read about for your first lab period. So, but something else that this calibrator can do is taking an input. And now, what about a device like a thermometer? I can actually output a signal to this thermometer and see if it reads what it should read based on a specific table for type K thermocouples. So what I'm going to do is I'm going to change this to an output, and I'm going to send a signal to my device. And voice. And as you can see, it displays a temperature now. And if I change the signal, it will cause a change in my temperature. And so that's something that you're going to explore on this part of the experiment. Now, halfway through the lab period, what you're going to do is you're going to switch. So this is a calibrating the input sensor, and then over on 620, the other station, you're going to look at the characterizing the final control element. And so that's where we're going to go